Question 10, Part B. In the diagram, Q is the point -1, 0, and R is the point 1, 0, and P is another point on the circle with center O and radius 1. Let angle POR equal alpha and angle PQR equal beta, and let tan beta equal M. Part 1. Explain why triangle OPQ is isosceles, and hence deduce that alpha equals 2 beta. In triangle OPQ, OQ is equal to OP because they are radii of the same circle, and that makes triangle OPQ isosceles. This also means the base angle of isosceles triangle OPQ are equal. So angle OQP, or angle PQO, which is equal to beta, is equal to angle OPQ, which is also equal to beta. Now this angle here, angle alpha, is the angle that is exterior to triangle OPQ, and the exterior angle of a triangle is equal to the sum of the opposite interior angles. So that's the sum of this angle here and this angle here. So they're both equal to beta, and that makes alpha equal to 2 beta. So looking at the proof, and it's written up here, OQ is equal to OP, since they are radii of the same circle, hence triangle OPQ is isosceles, and angle OPQ is equal to angle PQO, which is equal to beta, since base angles of the isosceles triangle OPQ are equal. Now angle POR is equal to angle OPQ plus angle PQO, and that's the exterior angle of triangle OPQ is equal to the sum of the opposite interior angles. So alpha is equal to beta plus beta, therefore alpha is equal to 2 beta as required. Part 2. Find the equation of the line PQ. Line PQ has a gradient of m, and the point Q with coordinates -1, 0 lies on PQ. And that's stated here. So line PQ has gradient m and point Q with coordinates -1, 0 lies on PQ. Hence, by the point gradient formula, y minus y1 is equal to m times x minus x1 in brackets, we have y minus 0 is equal to m times x minus -1 in brackets. Now x minus -1 is x plus 1, and y minus 0 is y. So y is equal to m times x plus 1 in brackets. Expanding the brackets, we get y is equal to mx plus m. Part 3. Show that the x coordinates of P and Q are solutions of the equation 1 plus m squared in brackets times x squared plus 2m squared x plus m squared minus 1 equals 0. The point P with coordinates x, y lies on the unit circle, which has equation x squared plus y squared equals 1. In other words, the coordinates of point P, when substituted into this equation, satisfies that equation. Now, line PQ with equation y equals mx plus m, which we found in part 2, is a chord on the unit circle. That means it contacts the unit circle in 2 places. Hence, the x coordinates of P and Q are found by solving simultaneously the equations x squared plus y squared equals 1 and y equals mx plus m. So by substitution, in place of y in x squared plus y squared equals 1, I'm going to substitute mx plus m. So the equation becomes x squared plus mx plus m in brackets squared equals 1. Expanding using perfect square expansion, mx plus m in brackets to the power of 2, we get x squared plus m squared x squared plus 2m squared x plus m squared equals 1. Now notice in the first 2 terms we have a common factor of x squared, so factorising out x squared, we get 1 plus m squared in brackets times x squared plus 2m squared x plus m squared. Now taking this one here over to the left hand side becomes minus 1, and that's equal to 0. Now this is the quadratic equation in x, whose solution gives the x coordinates of P and Q. Part 4. Using this equation, find the coordinates of P in terms of m. solving the equation from part 3 using the quadratic formula. And the equation from part 3 was 1 plus m squared in brackets times x squared plus 2m squared times x plus m squared minus 1 equals 0. So the values of a, b and c, where a is the coefficient of x squared, and that's 1 plus m squared, b is the coefficient of x, which is 2m squared, and c is the constant term, which is equal to m squared minus 1. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 2m squared plus or minus the square root of 2m squared in brackets squared minus 4 times 1 plus m squared in brackets times m squared minus 1 in brackets all over 2 times 1 plus m squared in brackets. So expanding the brackets here using difference of two squares expansion and also expanding the brackets here as well, we get x equals negative 2m squared plus or minus the square root of 4m to the power of 4 minus 4 times m to the power of 4 minus 1 in brackets all over 2 times 1 plus m squared in brackets. So expanding the brackets here, we get x equals negative 2m squared plus or minus the square root of 4m squared minus 4m squared plus 4 over 2 times 1 plus m squared in brackets. Now the 4m squared minus 4m squared cancels to 0, and we're left with the square root of 4. So x is equal to negative 2m squared plus or minus 2 all over 2 times 1 plus m squared in brackets. Dividing all terms by 2, we get x equals negative m squared plus or minus 1 all over 1 plus m squared. Now we know that the x-coordinate of P is positive. It's greater than 0. The other solution is the x-coordinate of point Q, which we know is negative 1. Hence, x equals negative m squared plus 1 over 1 plus m squared, which is equal to 1 minus m squared over 1 plus m squared. Part 5. Hence deduce that tan 2 beta equals 2 tan beta over 1 minus tan squared beta. The point P lies on PQ, hence the y-coordinate of P is given by y equals mx plus m, which we found in part 2. So going back to the diagram, there's line PQ, it has equation y equals mx plus m, and point P lies on PQ. And we found the x-coordinate of point P, which was 1 minus m squared over 1 plus m squared. So when x is equal to 1 minus m squared over 1 plus m squared, substituting this value of x into this equation here, we get y is equal to m times 1 minus m squared over 1 plus m squared in brackets plus m. Factorising out m, we get y is equal to m times, open bracket, 1 minus m squared over 1 plus m squared in brackets plus 1, close bracket. Now combining these two terms inside the square brackets, finding a common denominator of 1 plus m squared, and 1 is 1 plus m squared over 1 plus m squared, we get y is equal to m times 1 minus m squared over 1 plus m squared plus 1 plus m squared over 1 plus m squared. Now we have a minus m squared here, a plus m squared here, so they will cancel to 0, and 1 plus 1 is 2. So inside the square brackets, we get 2 over 1 plus m squared, and then multiplying that by m, we get y is equal to 2m over 1 plus m squared. Now consider gradient OP. So going back to the diagram, O is the origin with coordinates 0, 0. We now have the coordinates of P in terms of m, and the gradient of OP is equal to tan of alpha. So going back to the diagram, that's our angle of inclination, and converting that into a gradient, that's tan alpha, and that's equal to rise divided by run. So 2m over 1 plus m squared divided by 1 minus m squared over 1 plus m squared, and that simplifies to 2m over 1 minus m squared. Now gradient PQ, which is equal to m, and that's equal to tan beta. So again, going back to the diagram, That's PQ, its gradient is m, and that's equivalent to tan beta, which is the angle of inclination of PQ. And alpha is equal to 2 beta, which we found earlier on. So substituting tan beta for m and 2 beta for alpha here, we get tan 2 beta is equal to 2 tan beta over 1 minus tan squared beta as required.